Gentlemen, welcome back to the shop. Today we're talking about GPU acceleration in Cinelerra. For this video, we're trying to capture in 4K without a dedicated HDMI recorder, so things might be stuttering. This does not represent the actual speed of GPU acceleration. That's why we have a frames per second display. Check out the frames per second display, which is activated by right-clicking in the compositor, hitting Hide FPS or Show FPS. First of all, GPU acceleration in Cinelerra is for NVIDIA on Linux only. It's based on OpenGL shading and CUDA, and is not guaranteed to work on AMD/ATI or Raspberry Pi. After 40 years of trying to create a portable operating system, writing once, running anywhere, one language to rule them all, we still have to rewrite for every single new piece of hardware. The fact is, Cinelerra has always supported some kind of hardware acceleration since it was written. In the days when 200 MHz was screaming, hardware was originally the only way cheap confusers could play full-resolution, low-definition video. They read or wrote JPEG frames to an iOmega buzz or an LML33 card, which decompressed or compressed them. The video was shown on a separate CRT. Cinelerra had some support for those cards, but it couldn't do any processing during playback. Along 2000, along came the X-Video extension. These old video drivers still exist. If you go to Settings, Preferences, Playback, Video Driver, you'll find Buzz, X11, XV, and a few others. But they probably don't work anymore. Around 2000, along came the X-Video extension. That converted YAV 420 to an RGB overlay window in the GPU and scaled it. That was the first time we could play full resolution, low definition video on the X server, but it still couldn't do any processing in that mode. Finally, in 2006, Cinelerra got support for OpenGL in the playback pipeline, which you can see in the preferences as X11-OpenGL. This used a new feature in those days called the GL shading language. That would finally allow YUV to RGB conversion, and most effects to be done in the GPU by user-defined programs. Unfortunately, for many years in those days, GPUs and CPUs were basically the same in speed. There was really no difference when playing 1080p on a 1080p monitor, so the GPU support actually languished for 10 years and was mainly useless. Then, in 2021, the Lion Kingdom finally had enough money to upgrade to a 4K monitor. That really showed just how bad software had become. Holy hair pieces, the software mode was slow when trying to scale any video to the 4K resolution of that monitor. The newer, higher resolution monitors showed OpenGL was going to be essential for any kind of full-screen playback, and any resolution over 1080p. GPUs are once again much faster than CPUs. With modern video resolutions of 4K and modern displays over 4K, the X11 OpenGL mode is now the only practical mode of playback. The trick is, enabling OpenGL support is hard. All the Cinelerra binaries have it enabled, but if you're crazy enough to compile it, there's a test in the configure script. So if you want to compile it, you go in the build directory, and then you do /configure. This will do a test to see if you have CUDA installed, and then it'll test for all the other dependencies. And really all it does is it checks for the OpenGL headers, and if it finds those, it assumes you have CUDA as well. If it's satisfied that you have OpenGL, it sets the HaveGL flag in hvirtualconfig.h. That's this option right here. and it also sets it in hvirtual config, which is used by the make files. So we're just letting the configure script run as if it was actually going to build it, but I'm not crazy enough to build it from scratch. The trick is, you also have to use a commercial NVIDIA driver. The commercial NVIDIA driver is the only thing which has been tested with it. OpenGL in a virtual machine? Forget about it. If everything was compiled properly, and the driver works, you'll get an option in Preferences Playback for X11 OpenGL. Unlike other video editors, which absolutely require a GPU to work, Cinelerra still has the original software pipeline. That's enabled by selecting the X11 driver in Preferences. So Cinelerra uses a hybrid model for GPU acceleration. It processes whatever steps it can in the GPU. If something only works in software, everything before that step is done in the CPU. There's no way you can do a step in the GPU and follow that step by a CPU step. It only supports doing stuff in the CPU first, and then doing steps in the GPU next. This originated in the old AGP design, which had fast data transfers to the GPU, but slow data transfers out of the GPU. PCI Express is still generally too slow to transfer data in and out of the GPU. So the main assumption is moving data between the GPU and the CPU is slow. What happens in the GPU stays there until it's displayed. Let's compare software and hardware mode for a typical 4K operation, applying a defish effect to an action cam. So let's start out with just software mode. And then we right click on the track, attach effect. This is the defishing effect, lens. For benchmarking, you want to go to Settings, Preferences, Play Every Frame. So we're just testing the processing pipeline. We're not going to test how fast the file parser can drop frames, because that's always slow. And then hit the play button and see what happens. Watch your frames per second, which you enable by right-clicking in the compositor and hitting Show FPS. And you see that we're only getting about 14 frames per second in software. This video was originally recorded at 60 frames per second. So let's turn on OpenGL and see what happens. "60 frames per second. If we go full screen, it still does 60 frames per second. So that's the kind of necessity that GPU processing has become in the age of 4K. So what happens if we put a software-only effect after a GPU effect? If I attach a histogram and then enable the plot histogram feature, this can only be done in software. It has to read every pixel in the image, and it has to put all the color values into bins in order to draw the histogram, and that can only be done in the CPU. So if we do that, then it's falling back to software for the defishing, and it's super slow. 7 frames per second. But if we do the histogram before the lens by right-clicking on it and then selecting Move Up, we hit play, it's still doing this histogram display in the CPU, but now it's taking the lens out of the CPU, and we've gotten it up to 11 frames per second. So the ordering of the effects is very important. Another compromise that exists with GPU support is we don't support it for transitions. The trick with transitions is that they usually involve seeking to 2 points in the file, which is slow. Transitions are also a rarely used feature, and they're not normally used for resolutions that benefit from the GPU. The problem with all this back and forth between CPU and GPU processing is that it's not obvious what effects support the GPU and what only support the CPU. Motion tracking and histogram, with the plot histogram checkbox selected, are the two big ones which don't use hardware. If I'm playing back and I turn off the histogram, it's still performing whatever I set here, but it's not drawing the histogram. So it can do everything in hardware, and it can do the full 60 frames per second. So the easiest way to know what step is using the GPU or the CPU is to go to Settings, Dump Playback. And then if you go to your console, and just frame advance, you'll find it printing out a bunch of steps. So basically the steps where use GL equals 1, it's using the GPU. And if I play it back normal speed in 60 times a second, it'll show you exactly what it does for every frame. But what happens if I select automatic color for the histogram? Now it says use GL is still 1 for the histogram, but the step before the histogram is use GL 0. So why does the step before the histogram say it's using the CPU, while the histogram step still says it uses the GPU? The problem is the dump playback option only shows what each step is requesting from the previous step. So the histogram effect is requesting a software buffer from the file reader, but the lens effect is requesting a hardware buffer from the histogram. If a step doesn't read any input, then you're not going to know if it's using hardware. In that case, you're pretty much down to reading the source code or looking at the frame rate. One effect that doesn't read any input is the gradient effect. So let's create a new project. Let's select a region of the timeline. And let's attach a gradient effect. So here in the console, it's showing the gradient as the first step, but it's not showing the read frame call that comes before the gradient, because the gradient doesn't read any input. But since the gradient is giving 60 frames per second in 4K, you can be pretty confident that it's using the GPU. Say you want to benchmark playback frame rates. If you load that test file, the trick is to get it to play as fast as possible. There's no built-in way to do that. First of all, you have to go to the resource window, right-click on the file, and then you have to set the frame rate to a ridiculously high number, like 120 frames per second. So that's going to lie to the program about the file's source frame rate. You can right-click on it on the timeline, select Conform Project to Source. Then you're going to left-click on the right edge of the clip, drag it out, and this is going to automatically resize the clip to the length it would be if the frame rate was what you selected. If we go to Settings Format, you'll see it has now configured the timeline for 120 frames per second to match the fake frame rate that we set in the resources window. You've now lied about the frame rate to get it to play as fast as it can. The next thing you need to do is go to Settings Preferences and make sure Play Every Frame is enabled. You don't want it to drop frames because the decoders are very slow at seeking. They run fastest when they're reading 1 frame at a time forward. And the next thing you want to do is toggle between hardware and software mode to compare frame rates. Let's try software mode. It's going about 120 frames per second in software mode. If we go full screen, since this is a 4K monitor, it's maxing out at about 32 frames per second. That's why they made hardware mode. So go back to Preferences, select OpenGL, and now an interesting thing happens. It's only doing 60. If we go full screen, it's doing full screen a lot faster than it did in software mode, but it's still locked at 60. So an interesting thing happens when you use OpenGL, and it's also important when you're doing rendering. It's going to limit the frame rate to the synchronization of the HDMI signal, and it's only going to give you 60 output frames per second. It's something that doesn't happen in software because of the way the X server is configured. If you force it to play every frame and you hit fast forward, it's only going to do 60 frames per second, and you're not going to get fast forward. You'll absolutely have to disable play every frame so Cinelerra can drop frames in software. This has been an introduction in using GPU acceleration for Cinelerra. Hopefully somebody else will use it someday.